Good afternoon, my name is Daniel Henigan, and this is my second Capstone project for EET 490. It is called a DC adjustable benchtop power supply. Okay, so what I want to build is an adjustable DC power supply. They are pretty much the most popular piece of electronic technicians' test bench. They offer a wide range of application, and for almost every lab experiment we've done in class as well, we've used this. So the reason I want to build this is I just recently moved from New Mexico to California, and even though I'm using my local community college's lab anytime I need to do an experiment, my personal equipment is pretty limited because I used to rely on the school and working on base over at Cannon Air Force Base, New Mexico. But since I've lost those resources, it's been kind of a struggle, and I thought that this Capstone would be a good opportunity for me to build my own personal lab equipment, even though I do have access to the community college, but it would still be pretty nice to have my own. So I found a couple kits and schematics online that I have ordered. They are linear regulators, which means they aren't as efficient as a switching regulator, but and they also give off a lot of heat, but they're easy and compact, and they are an analog system. So I wanted to create something that is pretty dependable, that's dual channeled, and that has an LCD screen. So for that, I'll be using an Arduino. This kit I found online ships with all these components, which is pretty nice. Even though some reviews I've read, not all of them work. They come from, not the greatest sources apparently. But I've ordered 2 different types of kits, and hopefully one of them will work. These are the components in the kits, and even the component list was kind of difficult to get, so I had to kind of read into it. So what I'm going to be adding to these is I'm going to be having 2 of these kits in a project box for my dual channels. I'm going to have a switch between the channels for the adjustment. I'm also having banana plugs and not these little screw jacks that come on the board. So I will also be using fans and my own transformer to get the appropriate power. The maximum voltage is 28 volts VDC at 3 amps, and that's using a pretty beefy transformer, so I don't know if I'll get exactly to that. It might be a little less, and depending on the quality of components I get. It also doesn't come with any heat sinks or fans, so I'll have to do some temperature regulation on my box and some vents, because they do get pretty hot as it's a linear regulator. Oops, sorry. So yeah, I will be using 2 base kits to get the dual channel and make it a safe and portable box. I also don't know about the ripple voltage, exactly how hot it will be getting, or its power supply efficiency. So all these are not supplied with the manufacturer, so I'll need to take my own measurements and print them on the box so the user knows what exactly is going on in the box that I created. So that sums up my Capstone 2 proposal. I hope it'll be an interesting project. It'll involve some Arduino code again, and quite a bit of soldering, it looks like, as there's roughly 30 to 40 of these actually components per channel, along with the fans, the switches, the LCD screen. So it'll become quite a bit of a, hopefully not too chaotic in my box, but at the end, hopefully we get something that's fairly efficient and reliable with a set of instructions that anybody else could build the box if they wanted to. Alright, thank you for your time, and if there's any questions, feel free to contact me through Blackboard. Have a good day.